Hey guys, so for my project I chose to do the diamond in a square problem. I'll show you two ways of doing it and then we'll do a little harder way. So the problem is as follows. So ABCD is a square, ABCD, and M is the midpoint of side AB right here. And so by constructing these four lines, the blue shaded quadrilateral is formed, and we need to figure out what fraction of the total area is shaded. So this problem was hard for me at first, but I was able to figure it out using two methods, and I'm gonna show you. So the first method, first of all, I redrew the problem. Here I redrew it, and you can see A, B, C, D, and I drew the kite, the diamond, and I shaded it. But the first thing that's important to note is I added a couple new lines, that's a couple new points, which is gonna be important. The first one was point E, which is the midpoint of the entire square, right? It extends from point M, but it's the midpoint of the entire square. It's the intersection of these four lines, which are from opposite vertices. So by definition, this is the center of the square, okay? And then I drew this imaginary line from ME, which we know is parallel to AD and BC, right? That makes sense, how this line would be parallel to those two. And then I drew a line from there that goes through this imaginary point G. So I drew a line that goes all the way to this side. And then we drew point G. We have point H, where it hits this side, and point F, which is the center, that part of the kite. It's not the center of the kite, but it's an important point. So now we have everything we need. We have the center of the square. We have this part of the kite. We have point G. Point G is going to be super important. And then H. So now I'm going to show you the first way you can do it is using similar triangles and congruent angles, which I didn't understand at first, but hopefully it'll be easier to understand now. So the first important thing is that angle MGE, that angle right there, is the same as AGD. So this angle is the same as this angle, and that's because of vertical angles. Every time you have lines that intersect, the two opposite angles are the same. So this angle to this angle. And then we have angle GEM is the same as angle GAD. So this angle is the same as this angle. And that's because of alternate angles in a transversal. Every time you have two parallel lines, like we do with AD and ME, every time you have two parallel lines and there's a line going through them, the two alternate angles on opposite sides of the line are the same, by definition, in a transversal line. Therefore, triangle MGE is the same, is similar to triangle AGD, because once you have two angles, by definition, the third one must be the same, and that's why you have two similar triangles. Now we can start getting to solving. The most important part to know, though, now we're going to start solving, is that we know because E is the midpoint of the square, that means that line ME is half the length of line AD. So this line is half of this line. And then because we know they're similar triangles, once one line is half the other line, then all three, like once we know that the base is half, then this line MG is half of GD and EG is half of AG, because if they're similar, the same ratio must apply to all three of the lines. And then we also know the height, FG, is 1/2 of GH. And that's going to be the most important thing we have. So because of the different angles that are the same, we know we have similar triangles, and we know this triangle is half of this triangle. Okay, now we can get to solving. So I did this in two different ways. The first way, because it's a square, you could really have used any value. I did x to x, and I did 1 to 1. You could do 200 to 200 if you wanted. So I'm going to show you the x to x, and hopefully you'll understand it. So first of all, x to x, we know the base of the triangle. The base of the triangle is 1/2 x, because this point is the center of the square. So we know the base is 1/2 x. We need to find the height. All we know is that this line is y. We can say it's y, and this line is 1/2 y. Because of the similar triangles, we know that this height is half of this height, right? Just like here. So we can say this is 1/2 y and this is y. And again, because this is the midpoint of the square, we can say those combined equal 1/2 x. So we can say y plus 1/2 y equals 1/2 x. You solve using algebra, and we want to solve for 1/2 y. Not for y, but 1/2, because that's the height. So 1/2 y equals 1/6 x using algebra. You can see my steps. And then we know a triangle is base times height divided by 2. So our base is 1/2 x. Our height is 1/6 x. And then you solve 1/2 x times 1/6 x divided by 2 is 1/12 x squared divided by 2. But we don't need to divide by 2 because, as you can see here, we have 2 congruent triangles. That's only for one of them. But because we have 2, we don't need to divide by 2. We could just get rid of that. So the total area of the kite is 1/12 x squared, or just x squared over 12. So that's the total area of the kite. And the total area of the square is x squared. So now we want to find the fraction. We can say x squared over 12 divided by x squared, right? That's how we're going to find the fraction. Then you use keep, switch, flip to divide fraction. So you do x squared divided by 12 times 1 over x squared. And then you get x squared over 12x squared. And you can cancel out the x squared because you could cancel out factors in the numerator and denominator. And your answer is 1/12. Again, I did it 1 to 1. And the answer was still 1/12. So that's something super cool. I messed up at first when I tried using geometry. I messed up. This is really crucial. When I was trying to find the same angles, I said angle EMG, this angle, was the same to here, GAD. But that's not the case. Because of our alternate angles, this angle is the same as this angle. And this angle is the same as this one. So I got confused. You really need to know that it's alternate angles in a transversal and not on the same side. Okay, so hopefully you understood that. And then because I was confused, I did it one more way before we go to the harder. So I graphed it. You can see I graphed it on Desmos, but I'll just show you. Because we can use any type of length as long as they're the same, I did by tens. So this would be 0, 0, like on a graph. I didn't draw the graph, but on Desmos, you could see it's on a graph. And so you have 0, 0, this is 10, 0, this is 10, 10, this is 0, 10. And you already know this point is 5, 10, and this point is 5, 5. But to find the area, we need the height. So we need to know this point, K. So to do that, we need to find the intersection of this blue line and green line. So the green line is y equals negative x plus 10, and the blue line is y equals 2x. To find the intersection point, you set them equal to each other. So negative x plus 10 equals 2x, and you get x equals 10 thirds. But you need to find the y value, so you plug that back in, and y equals 20 thirds. So this point K is 10 thirds, comma 20 thirds. So then I redrew the triangle. We know that the base is going to be 5, and we need the height. The height can just be drawn as the change of x, right? From 5 to 10 thirds. So I did 5 minus 10 thirds equals the height, and the height equals 5 thirds. So I drew it again. Now we have a base of 5, a height of 5 thirds. Again, area equals base times height divided by 2. So area equals 5 times 5 thirds divided by 2. Area equals 25 thirds divided by 2. And again, we don't need to divide by 2 because we have 2 congruent triangles. So we're just going to cancel those 2 extra steps out. So the total area of the kite is 25 thirds right here. And the total area of the square is 100 because 10 by 10. So then we do 25 thirds divided by 100. Keep, switch, flip. 25 thirds times 1 over 100, which is 25 300ths, which if you reduce equals 1/12. So that's another way. That's how I did it at first before I understood the geometry. Okay, now real quick, I'm going to get to the next part, which is I thought, and you'll see why, it's not much harder, but it's super interesting. So hopefully we'll learn about the complexity of that a little, but I tried to do a rectangle. Instead of a square where they're equal to each other, I thought it could be different. If we have a rectangle, say length is 2 times the width, right? X, 2x. I kept all the same points, A, B, C, D, M, E, F, G, H. Okay, all the same principles apply. We know this angle is the same as this one. We know this one is the same as this one. And this one is the same as this one. Same rules because of alternate angles, vertical angles. We know the triangles are similar. We know that this base is 1/2 x. And we know that this base is x. So again, it's half of this triangle. And then again, FG is half of GH. So it's the same exact thing as the square. And then we can move on to the next part. So here I did the work. I wrote it x to 2x. And I also did it 1 to 2. And so again, same thing. This would be 1/2 y because it's 1/2 of this. And this can just be y. together they add up to x, because that's half the length, and then this part is 1/2 x, because it's half the width. So our base is 1/2 x, and we need to find, so now we need to find the height. So I set y plus 1/2 y to x equals x, and 1/2 y, that's what we're solving for to get the height. 1/2 y equals 1/3 x. That's a little different though than base times height divided by 2. So the area would be 1/6 x squared divided by 2, but we don't need to divide by 2. So our area is just x squared divided by 6. And the total area of the square this time is 2x squared. So it's a little different, but we do x squared divided by 6 divided by 2x squared. You can keep switch flip. X squared divided by 6 times 1 over 2x squared. You get x squared over 12x squared. And then you can just cancel out the x squares, and you get 1/12. And I forgot to show you, but I have it on Desmos again, which is how we get to the next part. So I did it 0, 0, 20, 0, 20, 10, and 0, 10. I did it by 20 by 10. Then the center point would be 10, 5, and this point would be 10, 10. So again, we need to find the intersection of the green and blue lines. I just found the equations. The green one is y equals negative 1/2 x plus 10, and the blue one is y equals x. Again, this would be on a plane, and that would be 0, 0. That would be 0, 0. So we set x to negative x over 2 plus 10. You solve for x, it's 20/3. We plug that back into the equation, which is super easy because we have a y equals x. So we know this point is 20/3 comma 20/3. And then I redrew the triangle. I said 20/3, 20/3, 10, 5 like we have here, and then 10, 10. And we know the base is, again, 5. We solve for the height, which is the change of x. So I did 10, which is this x, minus 20/3. The height's 10/3. So I drew the triangle, height 10/3, base 5. You get 50/3 divided by 2, but we don't need to divide by 2 because we have 2 of the triangles, same situation. So the total area of the kite is 50/3, and the total area of the square is 200. Then you do 50/3 divided, because 20 by 10. You do 50/3 divided by 200. You keep switch flip. You get 56/100, which can reduce down to 1/12. So every single time we get 1/12. But I was super confused. I was expecting it to be some weird fraction, like you multiply it by, like it's like 1/6 maybe, or 1/24, and it was still 1/12, which was super interesting. So, but I didn't believe myself, which is why it's super important to do both the graphing and the algebra and the geometry, because those, if you do both, you're more sure, because I didn't trust it when I did just one. But to check my work even more, I did 7 by 49, like 1 to 7 ratio, and I did the math. I'm not going to show you it, but I got 1/12 again. Then I thought, maybe what if, every time I've been doing 1 to a different number, what if I do 3 to 5? I did 30 by 50. I still got 1/12. And I did this probably 10 times. I had different numbers. I did the math. I got 1/12. So I've learned every time you have lines coming from the opposite vertices and lines coming from a midpoint, it's always going to be 1/12. I guess that's just the nature of a square, and it was super interesting to learn about how that works and why the dilations of the square lead to that. So thank you for watching, and see you.